Welcome. Today we're going to go over graphing all types of linear equations. So if you're struggling with graphing, by the time we're done with this, you should at least have some examples of all the different types we'll use. So let's get to our first type. So our first type of equation is actually graphing where you have a point and a slope. So if we look at this basic equation here, if we look at slope, slope is rise over run. And so this slope can be done 1 up and 3 to the right, or 1 down and 3 to the left. And of course that's a negative over negative, which makes that a positive, which is the same slope. So we start off by graphing the point, negative 1, 3, which is right here. And then we do the slope 1 up and 1 to the right. So 1 up and 1 and 3 to the right, 1, 2, 3. And so there's our next point. And then 1 up, 1, 2, 3 is our next one. And we don't have any more we can go there, so let's go and do the opposite one. So 1 down, 1, 2, 3 to the left, 1 down, 1, 2, 3. And we want to graph every point that we can. Then we want to connect our points with as straight as line as possible. Use your ID or something like that, or a straight edge. And then we have our graph. So I will try to go over how to graph slope each time so we can go over that. All right, we go to our next problem. All right. So here we have graphing a slope-intercept equation. So if we're going to graph a slope-intercept equation, the first thing we want to do is we want to take the equation and we want to solve it for y. So I want to subtract 2x from both sides. These are not like terms, so we get 3y equals negative 2x plus 12. Then I want to divide everything by 3. So we get y is equal to negative 2/3 x plus 4. All right, and so the y equals mx plus b. B is the y-intercept, which we always write as an ordered pair, 0, comma, whatever the y-intercept is. In this case, here's the letter b. All right, and then we have our slope. So here our slope is negative 2/3. So that is 2 down, 3 right. Or we could say 2 up, 3 left. One of the two has to be negative. So that's like the negative and the positive. Here's the positive and the negative, but they're always negative 2/3. We start off with the ordered pair. Remember, that's a 0, comma 4. So 0, 4 on the y-axis. All right. I always try to remember that b is pointing straight up and down to remind me to go on the y-axis. And then I graph the slope, 2 up, 1, 2, and 1, 2, 3 to the right. I can't go up again, so I do the reverse. 2 down, 1, 2, 3 to the... Oh, I'm actually graphing that one wrong. It's 2 down and 3 to the right. So 1, 2 down, 1, 2, 3 to the right. 2 down, 1, 2, 3 to the right. There we go. And then 2 up, 1, 2, and 3 left. 1, 2, 3 left. Notice I caught myself there real quick because I knew a negative slope line has to go down to the right. All right, and there's graphing with slope-intercept form. I would say the biggest issue with slope-intercept form is making sure you solve your equation over here for y correctly. If you mess up there, you're never going to have your graph right. All right, the next one is graphing an equation with x and y intercepts. This one takes a little bit of work, but it's not tough work. It just takes a little time. So the first thing we want to do is understand that x and y intercepts are. And so x and y intercepts are just ordered pairs. And so we have a point here, comma 0, and then 0, comma a number. So this is the x intercept because I'm going to find a number for the x value. And this is the y intercept. All right, and so all I do is I plug the value of 0 in to the y value. So I get 4x minus 3 times 0 equals 12. This goes away, so I got 4x equals 12. X is equal to 3. And so I now know my x-intercept is 3, 0. And I do it again for the other one. I plug in 0 for x. All right, once I do that, this goes away, and I got negative 3y equals 12. So y is equal to negative 4. And so then I put that up here, and then I graph just those 2 points. So 3, 0, that's on the x-axis, that's the x-intercept, and 0, negative 4 is on the y-axis. And then I just connect just those points, and that's my graph. So when you do x and y intercepts, you're only looking at just 2 points. All right. Let's go to our next one. So graphing from point slope form. So this is an equation in point slope form. So point slope is y minus y1 equals m times x minus x1, where the x1 and the y1 are points, and then you have your slope. All right, and so look carefully at this. You'll see that we have a negative here and a negative here, but over here in our equation, we have a negative here and then a positive. So there's been a sign change where that positive is. So this is why minus 3 equals 2 times x minus a negative 1. They simplified it to be that plus 1. This helps us pull out the ordered pair. The ordered pair is negative 1 comma 3. That number right here by the y was supposed to be a negative, so that's just a positive value, and that was the negative 1 value. Now that I got my point, I can also write my slope, which was 2. And that's a fraction, so it's 200, so that's 2 up and 1 right. Or I can reverse that and say 2 down, 1 left. So now let's graph this. So we graph the point negative 1, 3. When you're graphing, you only need a point. When we did the slope-intercept before, we had a point from the slope-intercept, and we used the slope to graph the other points. So this one's negative 1, 3, and then we have the slope of 2 up and 1 to the right. So 1, 2 up, 1 to the right, 2 up and 1 to the right. We don't graph every integer point that fits on there. So now reverse it, 2 down, 1 to the left, 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 2 down, 1 to the left. If you don't graph all the points, you might end up missing them on the graph, and so that can get you a deduction when you're doing some work on that. Connect them, and there's our line for graphing with point slope. So really it's just about pulling the point and the slope out, because that's all you need to graph. You either need 2 points or a point and a slope. All right, now graphing with horizontal and vertical lines. Now, if you can remember how this works, that's great. If you can't, then one of the things we always refer back to is Hoy-Vux. So Hoy-Vux is a little acronym to help us remember how to graph a horizontal and vertical line. So first of all, in Hoy-Vux, the horizontal line, h, the 0 is the slope of the line. The y equals is the equation, y equals the number. Vertical line, undefined slope, with the x equals the equation. Okay, and so that's everything that we have for that one. So now we're going to go back up and we're going to graph this. All right, so let's go back up so we can get this all locked in. All right, so let's look at this first one. So we got x is equal to 2. So that's an x equals an equation. So that's a vertical line. All right, and it has an undefined slope. So if we go where x is equal to 2 at, that's right here. And so what we're wanting is every line or every point that has x is equal to 2. And so if I look at, that's all these different points here going up and down that have x is equal to 2. And when I connect them, I can go straight up and down that vertical line, and that's x is equal to 2. Now if I'm going to do the y is equal to negative 1, y is a horizontal line. Remember, horizontal like the horizon, where they got the little sun. All right, and so we're looking at negative 1, and so we find the negative 1 on the y-axis, that's right here. And we want every point that has the negative 1 for the y value, and that's all these different points here. And when I connect them together, here I have y equals negative 1. And of course we had x is equal to 2. All right. And so that is graphing a horizontal and vertical line. Those can be easy if you get this process down and remember Hoy-Vux, and it can be difficult if you don't. And that's everything for graphing all the different types of lines that you may see in geometry and probably in Algebra 1 also. All right. And thanks for listening.